Hello and welcome to Round Robin. I'm your host, Robin McCormick with the City of Hampton. And today we are going to do something educational, fun, and different. We're going to do some hands-on science experiments like you can do at the Virginia Air and Space Center, especially during their summer camps. My guest is one of their educators, Natasha Jones.
Hi,
Welcome.
thank you for having me. I'm very excited to be here.
This is fun because you guys bring STEM education alive. It's not just books and theories, it is look how cool and fun this is.
Absolutely. I was actually with a school yesterday or on Tuesday, and I was doing all these awesome experiments that you're going to see today, and all these kids were like, it looks like magic, and I was like, but the best part is that it's not magic, it's actually science.
Well,
so I love that.
Science is a little magical.
Sometimes, yes, absolutely. Yes, absolutely, yes. We like to make science really exciting and hands-on for students.
So you guys do some really cool summer camps, week-long enrichment camps.
Yes.
That take kids a little deeper than, they can do in a one-day visit.
Absolutely. So we span all the STEM subjects. We have rocket camp, robotics camp, engineering camp, and we keep everything very hands-on, but also maintain age appropriate. So all of our camps, we start with rising kindergartners, those who are going into kindergarten, all the way up through 8th grade, and we keep everything age appropriate. So our kindergartners are not going to be with our 8th graders, but we do keep everything really hands-on. We have them engaged. We have so much fun, and we're teaching them science the whole time. But like last year for our engineering camp, the entirety of all of our different age groups built one very large Rube Goldberg machine. So at the end of the week, we had one huge Rube Goldberg machine that we set off in front of the whole center, and we blew out some balloons. It was wonderful, and every single age group had a part in making a part of that huge Rube Goldberg machine.
Oh, that is really fun.
Yeah.
And I think part of it is teaching, but also part of it is exposing. There are minority groups, young girls who aren't exposed to the coolness and the possibilities of a career in the STEM fields. And you can get them excited this way in a way you don't get excited in a science book sometimes.
Absolutely, and that's the benefit of our camps is that we, the big buzzword is bridging the summer learning gap, but we do that. We keep them engaged in science, we keep them excited about science, but they're still learning and we're still teaching them. And so it does help, bridge that summer learning gap, as we like to say, to keep them, keep their brains moving, keep their brains working while having a really amazing time and having memorable experiences.
And I will say, science is cool not just for kids, but for grown-ups too.
Absolutely.
So what did you bring for us today?
We brought liquid nitrogen, which is one of my favorites. So if you don't know what liquid nitrogen is, it is obviously the liquid form of the nitrogen air that we do breathe, but its liquid form is extremely cold. It's negative 321 degrees Fahrenheit.
Wow.
Very cold, which is why I have brought protective gloves.
Yay, because we're going to talk about safety.
Yes, absolutely.
These things as well.
Absolutely. So, but with having it be an extreme cold, one, it's an extremely important substance to NASA. They do a lot of testing with all of their materials before they send it up into space because it's just as cold as space, liquid nitrogen. But it's also, we can do these amazing experiments with it. And that's why I love it so much, because I can show students and adults and anyone who wants to come to the center or whoever I'm teaching that day, there's these amazing experiments that I can do right in front of you. And that's the best part that I love is seeing that wow factor and that look on people's faces. So today we're gonna do some really awesome experiments with some liquid nitrogen.
All right.
So first things first, I'll show you guys what it looks like. So it looks a lot like water, but because liquid nitrogen is so cold, it actually starts to immediately boil when it hits the heat of the room. And you'll actually see it start boiling. It's boiling just by me touching something that's room temperature, because it's probably about 400 degrees, and actually probably a little bit hotter than that out in this room. It's about 400 degrees hotter in this room than it is in the bucket. So we get an instant boil because it's so hot. I mean, this would be like if you stepped into your oven at 400 degrees. It's just so extremely hot that everything starts to boil right away. But like I said, because it's such an extreme cold and because we get this really amazing reaction of the boiling right just in room temperature, I can actually make this tea kettle whistle without any heat. So normally we would have to wait for the water to heat up on the stove for this to whistle for us and tell us it's time to make your tea. But with liquid nitrogen, and that's just going to boil off, and we'll actually see frost. We'll see frost form around the side of the cup, just kind of like when you see frost form in on your grass on crisp mornings. It's the same, basically the same thing. So I'm going to put some liquid nitrogen in here. And you'll see I am wearing my protective gloves.
Yay.
And that Miss Robin is not touching because we don't want to burn ourselves. So we can already see the steam coming out. So we're already making it whistle.
But you wouldn't want to drink that tea.
No, absolutely not. Yeah, so if you actually want to,
hundred.
yeah, if you actually want to feel the gas coming out, it feels very cold. Yeah.
Right.
So normally this would feel, so we're not having too much noise in here. Normally this would feel hot if we were, boiling water, but because liquid nitrogen is it's a cold boil, it feels very cold. And I mean, if you were able to touch this, it's very, very cold.
Right.
But you actually are able to safely touch it, touch the steam, as well as we're able to safely actually breathe all of this because we already naturally breathe about 78-79% nitrogen gas naturally in the air. So all of this is safe to do around students and safe to do around people as long as really the only people that are handling anything. And when we do have people come up and help us with experiments, and we usually have them either wear gloves or they're only really touching the materials that we give them. So like in this experiment that we do with the pennies, which I'll do now, you'll see that we'll only touch this, so that way we don't hurt ourselves. So I'm gonna go ahead and take these pennies. So I have 2 pennies, and we're gonna try and see if we freeze them, if they're gonna smash.
Okay.
So I'm going to go ahead and stick them in the liquid nitrogen. And the fun part about the liquid nitrogen is that as we saw when we bring it out into the heat, that it instantly starts to boil. But if I put anything into the liquid nitrogen, as we saw with our ladle and with the pennies and everything, it starts to boil right away from the heat of those objects. But then it cools down.
Because you're raising that temperature.
Exactly, I'm raising it, yes, immediately raising that temperature for about 400 degrees. So it's gonna boil right away. So as these marinate off, so we're gonna notice that one of these pennies will probably smash. One of these pennies will not smash, and we'll talk about why, and then also why that's important to NASA. So I'm gonna go ahead and take these out, put my gloves back on.
And these are like super, super frozen. This would not work in your freezer at home.
No, this would not work in your freezer at home. I mean, this is such an extreme temperature. Like we said, it's just as cold as space. So this is what's considered an extreme temperature. So we can do extreme experiments.
Okay.
So I'm gonna go ahead and put the top back on so it stays nice and cold. So I'm gonna place the pennies onto our carpet square here, and we're using this carpet square just so we don't, break any tables or anything.
Right, that's a good plan.
But if you want to try and smash these pennies,
let me try it?
absolutely.
Okay.
So try and hit this one first.
Nope.
One more time.
Oh, got it.
We got it. Awesome. Now try that one. Oh, they both broke.
I might have messed up your science there.
It's all good. It's okay. So sometimes this happens. Actually, we can see why. So normally, a penny that is made around before 1983 usually, they're made out of pure copper. And if we had one that was made before that, I thought I checked the years. Maybe I was a little wrong. That's okay. Science is fun. We can try it again. But the ones that are made out of pure copper actually do not break. We can smash them as much as we want. We'll see them bend maybe a little bit, but they will not break.
That's so cool.
Pure copper is an extremely strong metal, and it doesn't break under extreme temperatures and under extreme stress. Whereas a modern day penny, which we see obviously right here.
2000 and something there, yep.
And then this one, 1984, looks like.
And so as you said, though, there was a transition there, and you're not always sure which ones were pure copper.
Yes, exactly. But we can actually see the middle of the penny is like a greenish color, which is definitely not a copper color. It's actually made out of zinc. So modern day pennies, because around 1983, 1984, the United States government learned that it costs more than a penny to make a penny out of pure copper, because copper is very expensive. So they changed the formula to zinc with a copper coating, so they look like the old pennies. But the pure copper pennies are actually made out of, obviously made out of pure copper, and the pure copper pennies do not break. And actually, a lot of the metal that is sent out to space on spacecraft or satellites or anything like that, a lot of that metal is actually copper, because copper is such a strong metal, and it doesn't break under extreme temperatures.
And so that's why this is important and cool. Like,
yes,
the cool we
absolutely.
can see, but important is because we have to figure out which metals will work
exactly
in space
and
or on different planets.
You know, at the center we do have some NASA volunteer, interns that volunteer with us to, help us out with all of our really awesome experiments and all of our fun days. And I was speaking with a few of them recently, and one of them actually was working with a joint that they were testing, and they were testing it with liquid nitrogen for just one single joint. They're doing stress tests. And so I thought that was so cool. The same thing that we use to do all these amazing experiments and get kids excited about science is actually used for very important, materials testing for NASA to make sure that everything is safe for things to go out into space, which I just think is such a wonderful connection. All right, so the last experiment we're going to do is I'm going to try and make a cloud in your studio.
Okay.
So normally in the water cycle, we would have to wait for the water on Earth to evaporate, through the power of the sun and go up into the atmosphere where it gets really cold, and then it condenses back into a cloud, and then eventually that cloud would get really heavy and then precipitate. Now, we don't have that amount of time while I'm here with you, unfortunately, but I do have water that I've warmed up in my tea kettle. So this was an actual tea kettle that I had to warm up.
This is actually hot water.
Yeah, but we can actually see a little bit of the steam. So this water we already know is evaporating.
Okay.
And the two other ingredients you need to make a cloud is cold. Cold. And also a little bit of pollution, and there's probably, dust particles and everything in your studio, as there is.
We don't clean.
But so we're going to try and see if we can make a cloud, because I would assume that we probably have all of the ingredients to make a cloud. So.
Oh, wow. So. This is kind of awesome.
So this is the experiment where I get all my young kids to be like, oh my gosh, it's magic.
Look.
But the best part about it is that it's magic made from science.
Wow.
So through liquid nitrogen, we're able to teach about weather. We're able to teach about, the ways that NASA does testing for materials. If you've ever wanted to hold a cloud.
Yeah.
Go ahead, if you want to, go ahead. So yeah, through liquid nitrogen, we're able to teach about matter, about weather, about extreme temperatures, and about materials testing and the scientific method. And that's exactly what we teach in our camps. And so all of this, everything that we're showing you, everything's hands-on, everything is engaging, but we're still teaching those fundamentals of science and STEM, which we know are the careers of the future. So if we can, hook those students now and get them really interested and keep them engaged, then we would hope that through the Virginia Air and Space Center, we're building the next generation of STEM careers and STEM scientists.
Now, I'm just guessing some of these camps are going to fill up pretty quickly.
Yes.
So what should we tell parents right now about where to get information and how to sign up?
Absolutely. So you can go to our website, which is VASC, so Virginia Air and Space Center.org. And you can go to our camps page, and you can actually find all the really wonderful information. You'll find some quick information and quick descriptions of our camps on our website. You can purchase the camps from our website. If you have any questions, you can feel free to email camps, and that's at vasc.org. Or you can call our camp line. The direct extension is 780. We would love to answer any questions that you might have. And we really hope that you would really enjoy having your students and your kids come hang out with us for a whole week. We would love that.
That is awesome. And if we can't commit to a whole week, or, those are a little pricey, they're worth it, of course.
Absolutely,
but some people could maybe do a Saturday or see a demonstration on the floor, get the kids excited.
Absolutely.
That's the other thing. Kids might be, science camp. But if you show them, give them that little taste first,
maybe they'll get excited about it.
Go.
Absolutely. So every first and third Saturday of the month, through June, we have what are called STEM Saturdays, where we do, and every Saturday is a different theme. We do amazing, fun, hands-on activities right on our exhibit hall floor. It's all part of your admission that day. And then during the summer, we have our Summer STEM series, where every day we have different STEM and hands-on activities for your students to come and experience, and it's all part of admission that day. And we would love to have all of you come to our camps. If it works out that you unfortunately can't come to our camps, we would love to have you on those STEM Saturdays, and we would love to see you in the summer for all of our STEM STEM activities on the floor.
Thank you so much.
Thank you for having me. I'm excited to be here.
And thank you for watching. I hope you will think about this for your kids. Show them this video. Let them get excited about the fun and wonderful things they can do and learn kind of on the side as they go. And check out the website for more information. Thanks for watching.
Thank you.